In this video, we will take a look at the Singleton design pattern. We will talk about its characteristics, see how to implement lazy loading, which improves startup time, as well as reduces resource wastage in creating an object which may not be used. Finally, we will also see how to make it thread safe. A Singleton class guarantees only one instance of the class to be created throughout the software system and often provides a simple access to the instance. They are useful for objects which are costly to create, like the database connection. It would be very expensive to create a separate database connection for every object. Other examples where they are commonly used are loggers, configuration manager, runtime instance, etc. The Singleton class has a private instance of the Singleton object. There is no public constructor to the class, so it cannot be instantiated by consuming clients directly. The constructor does not take any arguments, and the clients obtain the reference to that sole Singleton instance by a public method typically called getInstance. So let us start creating our Singleton class. Here I have Spring Tool Suite running on my machine. However, feel free to use any other editor of your choice. I have a simple Java project I am calling Singleton Pattern. Let us right click on our project, choose New, and then Class. Call it Singleton Class. Click Finish. The Singleton class would have a private instance variable, so we have here private static Singleton class. Call the instance variable as instance and instantiate it as a new Singleton class. This is eager instantiation. We will look at lazy loading soon. The second characteristic is a no args, non-public, here a private constructor, so it cannot be called by outside classes. And then finally, we have the public static Singleton class getInstance method, which would be invoked by external clients to get a reference to the instance. Let us test this Singleton class. So right click on the default package and choose New Class. Call it Tester. Click Finish. Let us create a main method inside which let us create an instance of this class called Instance1. Since it does not have a public constructor, we cannot instantiate it by using the new keyword, but we will use the static method Singleton class.getInstance. Let us create another instance called Instance2. Let us print the object address of the two instances. Let's run this class, so run as Java application. Since there is only one instance which exists and which is returned back when the client calls the getInstance method, we see the same object address. Now back to our Singleton class. Right now we are doing eager loading where the object is instantiated right away, even though it might never get used. Also, this would increase the startup time of the application. So another approach to instantiation can be lazy loading, where we instantiate the object only when and if we need it. So let us make the instance as null here. Now inside the getInstance method, let us put if instance is null, only then instantiated, otherwise just return the previously instantiated instance. So for the first time when this object is needed, it will be instantiated, and from then on, every call will return the previously instantiated instance. This approach, called lazy loading, can lead to great increase in performance. Let us go back to our test class, run it again, and again we see that still only one object address is returned. Finally, let us make this class as thread safe. First, let us put the volatile keyword to the variable, which guarantees variable visibility across threads. The value of this variable will never be cached locally in a thread, but all reads and writes will go to the main memory, and so all threads will read and write from the main memory. Next, let us put the synchronized keyword around the instantiation. We could have put the synchronized keyword at the getInstance method level, but that would have been more expensive. Now, further, inside let us check the condition. If instance is null, then instantiate. This might look very confusing and unnecessary, but say the first time when this variable is accessed, two threads simultaneously call this method. Let us say thread A and thread B. Say thread A gets a lock on the synchronized block and thread B is waiting on the lock. Thread A will instantiate the variable and then release the lock. Thread B will then get the lock and will instantly get inside the synchronized block, and if there was no check done for the instance nullness, it will instantiate it again. So to prevent that, we do a second check inside. One last thing we can do is to prevent anyone from instantiating this class using reflection. So inside our private constructor, let us put if instance is not null and someone has gotten to the constructor using reflection, throw a runtime exception stating not allowed to instantiate directly. So that is it. Let us go back to our test class and run it again. We get a single object address, and so our changes are successful. In this video, we saw the characteristics of a singleton class, namely a single private instance, a non-public, no-argument constructor, and a static method which returns the reference to the sole singleton instance. Next, we saw how to code for lazy loading, which creates the object instance only when needed and reduces startup time of the application. Finally, we saw how to make the class thread safe. Thanks for watching.